Alright, we're going to just talk about how to solve these problems in this packet. Not necessarily give you the final numbers, but just go an overview of how to do them. So angle of elevation and depression are always from horizontal, and the key is whether you go down or up. So if it's horizontal down, it's depression. Horizontal up, it's elevation. Angle 3 is horizontal down, which is depression, and angle 4 is horizontal up, which is elevation. For our next problem, we're given lots of pieces of information. We need to identify the pieces, so I'm looking at angle of elevation. That's opposite, that's adjacent, which means I have a tangent value. So tangent of 35 is x over 200. You can multiply by 200 and you'll get you x. Now you got to remember that you're 5 feet off the ground, so you add that to the number. It gives you the actual value. Alright, I have an airplane. I have a 2-degree angle of depression. I assume that's a right angle there because it's an altitude, so it's straight down. And then I have the opposite and the hypotenuse. So that's going to be a sine problem. Sine of 2 degrees is 3500 over x. Now be careful, don't just put your variable in the numerator. It's the hypotenuse, so it's in the denominator. One way to solve it is to make it a proportion and then you cross multiply. Either way you get 3500 is sine of 2 degrees. Divide by whatever that number is, sine of 2, and you get your value for x. This one I need to draw pictures, so there's my best sketch of the Statue of Liberty. And I have an angle of depression, so I start from straight out horizontal. I look down to the ship that's in the water. And so I have a 90-degree angle and an 18-degree angle of depression. And so the 250 feet of the Statue of Liberty, it comes over to be that piece of my triangle. And what I'm looking for is the adjacent side, that leg of the triangle. So it's adjacent and opposite, which is tangent. So tan of 18 is 250 over x. I can solve that again however I want with cross multiplying. I'd multiply by x and I get my value for x. Alright, this one I have a flagpole. It's 90 degrees, it's 282 feet tall, and I'm dealing with a shadow on the ground, so it's 137 degrees. I'm looking for that angle there. Again, it's an elevation, so it's up from a horizontal, and so it's tangent. Opposite and adjacent give me a tangent value. Now to get x by itself, to undo that tangent, I use a tangent inverse. So it becomes tangent inverse of my ratio. Plug in a calculator, see what I get. Alright, this one's a little trickier. We'll draw it a little bit bigger so we can see. But I have 51 meters, a right angle, and then 15 degrees. Now both of those are horizontal, which means they're parallel, which means that that is also 15 because they're alternate interior angles. And so that allows me to figure out that side x. So I can solve that side x using tangent. And that gives me the top piece of the building. Now, what I'm missing is from this piece down, which is actually the other building. But I can do that because I can take away from the whole height of the building. The whole height was 207. I take away x. That leaves me with what the actual other building will be. This one I'm looking for this top piece, this difference here. And so I can set up and use the two triangles that I have. So I have the green triangle, which is 42 degrees, 75 feet, and the red triangle, which is also 75 feet and 28 degrees. And so I have two heights, h1 and h2. They are both tangent problems, which means that I can set up my ratios. And once I figure out h1 and h2, that difference in values is going to give me the height that I'm looking for from the top to the windowsill. Alright, getting into the review problems,